Hello everyone, welcome back to High School Mathematics channel. Today we are going to learn class 10 chapter 1 real numbers exercise 1.4. See now question number 1. Prove that the following are irrational. First one is 1 by square root of 2. Let us see the solution. Let 1 by square root of 2 be rational number. Then there exist positive co-primes A and B such that 1 by square root of 2 that equals to A by B. That implies we have multiplied this denominator B value for the numerator. So that implies B by square root of 2 that equals to A. 1 into B means B only. So B by square root of 2 that equals to A. That implies B equals to A into square root of 2. Here denominator square root of 2 is there. On transposing it became multiplied. So B equals to A into square root of 2. That implies square root of 2 equals to. Here A is going to multiply. On transposing it becomes divided by. So square root of 2 equals to B by A. So we got square root of 2 equals to B by A. Here B by A is rational number. Why? Because A and B are integers. Therefore square root of 2 is rational we got, but which is contradict to the fact that square root of 2 is irrational number. Hence our assumption is false and 1 by square root of 2 is irrational. See now question number 1, second sum, square root of 3 plus square root of 5. Let us see the solution. Let square root of 3 plus square root of 5 be a rational number. Let square root of 3 plus square root of 5 that equals to P by Q, where Q value is not equals to 0 and PQ belongs to integers. Now we have to do squaring on both sides. That is square root of 3 plus square root of 5 whole square that equals to P by Q whole square. Now this part is looking like A plus B whole square. So let us expand that. A square plus 2AB plus B square. That means square root of 3 means square root of 3 whole square, just like A square, plus 2AB means 2 into A value square root of 3 into B value square root of 5 plus B square means root 5 whole square that equals to P square by Q square. Now here square and root were cancelled, 3 plus 2 into square root of 3 into square root of 5. Both values we can multiply. So the answer is 15, that is 2 root 15 plus here square and root both were cancelled. So plus 5 that equals to P square by Q square. 3 plus 5 that is 8. So 2 root 15 plus 8 that equals to P square by Q square. That implies 2 root 15 that equals to here plus 8, on transposing it is minus 8. So 2 root 15 equals to P square by Q square minus 8. We got 2 root 15 equals to P square by Q square minus 8. That implies 2 root 15 equals to, here we shall do LCM, so P square minus 8 into this Q square multiplied here. So P square minus 8 Q square by Q square. That implies here 2 is going to multiply, on transposing it becomes divided by. So square root of 15 equals to P square minus 8Q square by 2Q square. Here square root of 15 is an irrational number and here we got P square minus 8Q square by 2Q square. This value is in the form of P by Q, so it is a rational number. But an irrational number can't be equal to a rational number. So our assumption is wrong that square root of 3 plus square root of 5 we have taken as a rational number, but here we got irrational number. Therefore square root of 3 plus square root of 5 is irrational. See now first question, third sum, 6 plus square root of 2. Let us see the solution. Let us suppose that 6 plus square root of 2 is a rational number. Then we have taken 6 plus square root of 2 equals to P by Q, where Q value is not equals to 0. That implies square root of 2 equals to P by Q minus 6. That is here plus 6, on transposing it is minus 6. That implies square root of 2 equals to these two are two rational numbers. So it is difference of two rational numbers. That implies square root of 2 equals to difference of two rational numbers is also a rational number. So we got here square root of 2 equals to rational number. But it contradicts the fact that square root of 2 is an irrational number, but here we got it is a rational number. So our assumption is wrong. Therefore we can say that 6 plus square root of 2 is irrational. See now first question fourth sum square root of 5. We have to prove that square root of 5 is irrational number. Let us see the solution. Let us suppose that square root of 5 is a rational number. We have taken square root of 5 equals to p by q, where q value is not equals to 0. If p and q have a common factor, on cancelling the common factor, let this p by q reduces to a by b, where a and b are co-primes. Now square root of 5 is equals to a by b, where HCF of this a and b is equal to 1. Now we shall do squaring on both sides. We get square root of 5 whole square, that equals to a by b whole square. We got square root of 5 whole square equals to a by b whole square. Here square and root both will be cancelled. So that implies 5 equals to a square by b square. That implies here b square is dividing, on transposing it will become multiplied. So 5b square equals to a square. Here 5 divides a square and thereby 5 divides 5. Now we shall take a value equals to 5c. Now we shall do squaring on both sides. Then a square equals to 5c whole square. That implies a square equals to 5 square means 25c square. So a square equals to 25c square. That implies here we got a square value is equals to 5b square. So we substitute that value here. So instead of a square we have written here 5b square equals to 25c square. Now dividing both the terms by 5, we get here b square equals to 5c square. That implies 5 divides b square and thereby b. So that implies 5 divides both b and a. This contradicts that a and b are co-primes. This contradiction arises due to our assumption that square root of 5 is a rational number. Hence our assumption is wrong. Therefore square root of 5 is irrational. See now first question fifth sum 3 plus 2 root 5. Now we have to prove that 3 plus 2 root 5 is irrational. Now let us see the solution. Let us assume that 3 plus 2 root 5 is a rational number. Therefore 3 plus 2 root 5 equals to p by q, where q value is not equals to 0. Here plus 3, on transposing it becomes minus 3. So that implies 2 root 5 equals to p by q minus 3. That implies 2 root 5 equals to, here we have to do LCM. So LCM value is q. So p minus 3q by q. This q is multiplied here. So p minus 3q by q. That implies square root of 5 equals to p minus 3q by 2q. Here 2 is multiplying, on transposing it becomes divided by. Here this value p minus 3q by 2q, it is in the form of p by q, so it is a rational number. We know that root 5 is irrational number, but here this value is rational number. This shows that this contradicts the fact that square root of 5 is irrational. Hence our assumption is wrong. Therefore we can say that 3 plus 2 root 5 is irrational. See now question number 2. Prove that square root of p plus square root of q is an irrational where p comma q are primes. Let us see the solution. Let square root of p plus square root of q be rational number. That implies square root of p plus square root of q that equals to a by b, where a and b are co-primes and integers. Now let us do squaring on both sides. So after squaring, this square root of p plus square root of q whole square, it becomes this value a by b whole square. So that first part is looking like a plus b whole square. So if we expand a square, that means square root of p whole square, plus 2ab means 2 into square root of p into square root of q, plus b square means square root of q whole square, that equals to, after squaring this value, a square by b square. Here square and root will be cancelled, so p plus, here square and root will be cancelled, q plus 2 into these two values are multiplied, so square root of pq, that equals to a square by b square. Next step, that implies 2 root pq, that equals to a square by b square plus p and plus q on transposing, they are minus p minus q. So that implies 2 root pq equals to, here as a value will be b square, so this value will be multiplied for p and q. So 2 root pq equals to a square minus pb square minus qb square by b square. We got previously 2 root p, that equals to a square minus pb square minus qb square by b square. Here 2 is going to multiply, on transposing it becomes divided by. So that implies square root of p equals to a square minus pb square minus qb square by 2b square. Let us assume that this is equation 1. From equation 1, our assumption contradicts. Why? Because square root of p equals to, this is in the form of p by q. So it is rational. So p value is rational. Therefore it is contradict to our assumption. Square root of p is irrational, but we got here rational. Hence we can say square root of p plus square root of q is irrational number. Today we have seen class 10 chapter 1 real numbers exercise 1.4 all sums. Hope you all like this video. If you like this video, please like, share to your friends and subscribe to our channel. Thank you for watching.